Solving systems of equations by graphing. So on a coordinate plane, if we have two lines drawn, they can have a point of intersection. If they do intersect, this would be considered the solution of the system of equations. But in general, on a coordinate plane with two lines, we can have three different cases, three possibilities. The first case is where the two lines intersect in exactly one point. The second case is when the two lines are parallel and never intersect. And the third case is when the two lines are the same or they coincide. So we have coinciding lines. And in this case, every point along the lines is a point of intersection. So in the first case, we have one intersection point. In the second case, we have no intersection points. And in the third case, we have an infinite number of intersection points. Okay, let's look at an example. Let's use a graph to determine where the lines x plus y equals 6 and 2x minus y equals 6 intersect. The first thing we're going to do is to write each equation in slope-intercept form. That means get y by itself. So let's take the first equation. Let's move the x to the right-hand side. We get y equals negative x plus 6. Remember, the 6 is the y-intercept. The slope will be the number in front of the x, which is negative 1. In this case, negative 1 over 1. So on a coordinate plane, put a point at 6 on the y-axis, and then go down 1, right 1. And I do a few more to kind of draw a straight line. Okay, so this first line is x plus y equals 6. Okay, the second equation, 2x minus y equals 6. Let's subtract 2x. Let's divide everything by negative 1. Y equals 2x minus 6. So our y-intercept will be negative 6, and our slope will be 2, or 2 over 1. So put a point at negative 6 on the y-axis and go up to right 1, and draw on my line. Okay, so I have a point of intersection, and the coordinate here, since I've drawn it carefully, is 4, 2, or x is 4 when y is 2. That's the solution to my system. So the point of intersection is 4, 2. We can check this answer by checking this point into both equations. So I would substitute 4 in for x and 2 in for y. For example, with the first equation, x plus y equals 6, substituting in the 4 and the 2, does 4 plus 2 equal 6? Yes, it does, so it checks out. And it needs to check out in the second equation as well. The second equation is 2x minus y equals 6. Substituting in 4 for x and 2 for y, does 2 times 4 minus 2 equal 6? 8 minus 2, does that equal 6? Yes, it does. So it checks out in both. Finally, solving systems with a table. And what we're going to do right now is look at a table using the graphing calculators. So for example, we have a system y equals negative x plus 6, y equals 2x minus 6. This was the one we just graphed. If we enter those two equations in y1 and y2 on our graphing calculator, we can then look at a table. on the graphing calculator by hitting second graph. And if you look carefully, you'll be able to tell for which x both y1 and y2 have the same value. And we see it right here when x is 4, y1 is 2, and y2 is 2. So this is the point of intersection, 4, 2. And so this corresponds with what we found on the graph.